All right. So this lesson, we're going to talk some more about function behavior, and one of the behaviors we're talking about is even and odd functions, which we just did that activity over. And the other thing we're going to talk about is where a function is positive and negative. So let's start with even and odd. So a function is going to be an even function when you plug in negative x and you get the exact same thing as the original function, same thing as f of x. All right, now this one is a lot like the one you guys did. So it is an example of an even function because we can put negative x in for x. And then what happens when you square a negative? So positive. So negative x squared is just x squared. And these two things are exactly the same. And when they are exactly the same, it is an even function. Right? And what we have already learned about even functions is that they're symmetric about the y-axis. And that is easy symmetry to spot on the graph. The origin symmetry is a little more difficult to see, but y-axis symmetry, you recognize that from years and years of learning about symmetry. We're also going to need to be able to look at a table and determine if the graph is even or odd. And so for the even functions, opposites are paired with the same number. We'll say same y. Opposites are paired with the same y value. So negative 5 and 22 and positive 5 and 22. So same number. All right. So let's talk about odd functions. An odd function, when you do f of the opposite of x, it should give you the opposite of f of x, or negative f of x. All right. So if we need to check algebraically, we're going to put negative x in for all of the x's. And then what happens when you cube a negative? It stays negative. And then negative 3 times negative x is going to be positive 3x. So that is what it looks like when they're opposite. Every sign changes on opposite, and that's going to be an odd function. Yes, ma'am.
This isn't related to the lesson.
I don't. I have some paper towels. All right, so for symmetry, odd functions are symmetric about the origin. And that symmetry looks like this graph. So you can think of it reflected on the x and the y, or rotated 180 degrees. And then from the graph, one thing that has to happen, I don't think we talked about it on the activity, is 0 must be paired with 0. So it's possible that 0 isn't paired with anything, like it doesn't even touch 0. That can happen on odd functions. But if it touches 0, the graph touches 0, it has to be at the origin for origin symmetry. And then opposites are paired with opposite y values. Right? And that looks like negative 1 is paired with positive 2, so positive 1 is paired with negative 2. or negative 4 is paired with negative 52, so positive 4 is paired with positive 52. So that's what origin symmetry looks like on a table. Okay, so on our example, we have 4 different functions represented 3 different ways, and we're going to determine if they're even, odd, or neither. Now, someone in my last class was like, can't we just look at the exponents and know? Not really. Now, the more of these you practice, then probably. But if you were just looking at the exponents on A, what would you say it was? You would say it was odd. So let's see. So we're going to check algebraically by plugging in negative x for all the x's. And then when I have a negative raised to a odd, I do get a negative. But that negative 1 or that minus 1, is it going to change? No. So if all the signs don't change, then it's going to be neither. There's tons of functions that are neither. Like even in odd functions are special functions. Ton of them are neither. So if all the signs don't change, you can't say it's odd. Now, like I said, the more of these you practice, you're probably going to get to a point where you're going to kind of be able to recognize it. All right, let's check B. So we're just going to put negative x in for x. And I know when I raise a negative to an even power, I am going to get a positive. So what do you think? Even, odd, or neither? This one's going to be even. They are exactly the same. Okay. What do you guys think about C? Even. It's actually the graph of the cosine of x, which you're going to learn, but not yet. All right. What about D? Odd. Opposites are paired with opposites is odd. And 0 is paired with 0. That's important. Okay, the other thing we're going to talk about today are where graphs are positive and negative. Now, I didn't want to do this on the same day as increasing or decreasing because it's really easy to get those things mixed up or think that increasing means positive, and it doesn't. So for increasing, a graph is going to be increasing if it's rising from left to right. So the graph is rising from left to right. Now, yesterday, we said it had a positive slope. I'll draw a graph with a positive slope, but that doesn't mean it's positive. So some people get positive slope and positive like as the same. It's not. Now, a graph is going to be positive where it's graphed above the x-axis. Okay, so totally different things. Completely unrelated, actually. All right, and then decreasing, we're just going to kind of reword it. So instead of rising from left to right, we're going to be falling from left to right. Yes. So this one, the decreasing intervals is where the graph falls. The negative intervals is totally unrelated to that. It's going to be where the graph is below the x-axis. All right. So in that big space we have, we're just going to draw just a random little graph that's shaped like a kind of a wide parabola. All right, so I want you guys to just put a mark at the x-intercept on the left, and we're just going to call that A. All right, put a mark where you have the vertex, we're going to call that B. And then the x-intercept on the right, we're going to call C. All right, and we're going to do all the different types of intervals using A, B, and C, because that's all we need. We only need x's to do these intervals. The y's do not matter when we're doing the intervals. Okay, so we're going to give the increasing interval. So the graph is increasing when it's rising from left to right, which should be this. I don't know what just happened. It should be this right here. So how would you describe those x's? What? Using A, B, and C. B to infinity, right? Okay. And then the new stuff is positive intervals. So where the graph is positive is above the x-axis. So we have two sections of the graph where it's graphed above the x-axis. Yes.
Is that only x values as well?
Yes, sir. All right. And what's the other one? Very good. All right. And then decreasing interval. We have one decreasing interval. What do y'all think? Negative infinity to B. And then one negative interval. So the graph is negative when it's below the x-axis. So A to C. Very good. All right, I'm going to have you guys try example 2 on your own. On example 2, though, we have actual numbers. So each little mark is going to represent 1. And so give the intervals of increasing, decreasing, positive, and negative, please. Robbie, can you put your computer away? All right, what do you guys think about increasing? Decreasing? Positive? Negative? Good job. All right, what questions do you guys have? All right, the last thing we're going to do The last thing we're going to do is determine the intervals in which a function is positive. So for something to be positive, how does it relate to 0? Greater than 0. So positive is greater than 0. What about equal to 0? Greater than or equal to? Is 0 positive? No, 0 is neutral. All right, so what we're going to do is we're going to take this function and we're going to say that it's greater than 0. What if it had been negative, just for example? Be less than 0. Okay, so this one's positive, so we're going to do greater than 0. So this goes back to what we did in the first units. So how do we solve quadratic inequalities? You could solve it that way. What we're going to do is do the test intervals. I know it's everybody's favorite thing. So how do we figure out the numbers that we label on the number line? Yes, so first we want to find where this equals 0. And we are going to factor it to do that. Okay, so I have -2 and I have 4. And then we're going to test a point in each region. Now, someone in my last class was like, can't we just kind of know what that graph looks like and know, it's going to cross the x-axis at -2 and 4 and then kind of know where it's going to be above and below? And if you know that, absolutely. That's great. If it is a graph that you don't know what it looks like, then you definitely need to do the test intervals. All right, so we really just want to know if when I plug in -3, if I get a positive. And so we could actually plug it in, or we could just figure out if it's positive or negative. So I'm going to plug it into the factored form. So if I do -3 minus 4, I know that that is a negative. And if I do -3 plus 2, that's a negative. If I multiply those, what am I going to get? Positive. So this is a region where it's positive, which is what we're looking for. Now 0, I would plug into the original. So that's going to be -8. So that's going to be negative. All right, and then 5, same thing. I can plug in here. It's going to be a positive times another positive is going to be a positive. So I have 2 solution regions, this region and this region. Do I need to include -2 and 4? No, because 0 is not positive. So our solutions are going to be from -infinity to -2 and from 4 to infinity. Now I went ahead and I wrote the answer like we did when we saw these before. If you just do a comma and not the U, it's fine.